Spryker new e-commerce framework. Ben Longden, our CTO in London, Stampede office from Invika, will tell you a bit about it. We are happy to have you here. Hope you enjoy it. You saw the drinks. There will be more food outside later, and hopefully some socializing, networking, whatever. So enjoy.
Alright, hi everyone. So this is a talk that I'm kind of prepping really for Code Talks in Berlin, in the e-commerce version of it, which is at the end of this month. It's kind of technical. I was kind of, obviously this is a Symfony user group, so you guys are going to be all quite technical anyway. So, and it goes into depth about the architecture of Spryker, what makes it special, what makes it kind of unique, certainly within PHP e-commerce platforms, and both why it's unique in terms of the way that you set the whole thing up, but also how it's built internally. There are two ways of looking at the architecture of the platform, which I think are quite exciting actually, and certainly worth delving into. That's me. I'm Ben. That's me on Twitter. That's the easiest email address to remember that I actually have. And that's what I'm here to talk about. I'm not going to focus on not really any of the features, maybe one or two of the ones that are important for our development audience. I'm going to focus on any of the things that it will do for you as somebody who wants to buy an e-commerce platform. I want to talk more about what actually makes it interesting from a development perspective. It's not a sales pitch. I don't work for Spryker. I just think it's really good. I've had about 5 years experience, maybe more than that actually now, probably more like 6 experience working on e-commerce platforms. Most of those have been with Magento. I've had a little bit working on some of the really early versions of Silius, which is kind of more Symfony based, I guess. Actually, how many people have actually used Silius? Or looked at it even? Okay, cool. And for the last 12 months, this has been the platform that I've been doing most of my e-commerce work on. We've managed to complete one project in Vika on the Spryker platform. We're working on number 2. And both of them have actually been really quite fun projects to work on. Spryker themselves are based in Berlin. They were spun out of Project A Ventures, so they got some kind of Series A funding in June in about 2015. So they're building that whole platform out based on the fact that kind of Series A investment, going out there looking for how to get this product into the market. But actually, the first thing I want to really touch on is the concept of a layered system. And this is something that I've talked about for years and years at conferences and events like this. Most of my talks are actually on APIs and designing RESTful APIs. And if anybody is familiar with the 7 RESTful REST constraints that Roy Fielding came up with in his thesis, a layered system is one of them. And actually all he was really doing is describing how the web works. And by a layered system, I think this diagram kind of describes what it is. It's not very high quality, apologies for that, but what it means is that you can be a browser over here talking to a backend server over here, but you don't know what is in between the browser and that backend system, all the way over there. And most of the time, you can't control what these things are that are between the browser and the cache. And with the exception of the one that's actually inside your environment. So, how many of you used tools like Varnish before, or Nginx and reverse proxying and caching and using Nginx? So those are cache servers that you can control that sit within your environment. And the only reason, literally the only reason why the web works at all is because this is in place. If it didn't work, and every connection was from browser straight the way through to the backend server, I don't know how much compute power you would need to be able to actually run this stuff using things like PHP and Python. But yeah, it won't work, let's put it that way. Now, and this system, it does work, and it's great, except it does come with a couple of particularly thorny issues. And most of the systems that you work with, that we look at when you're looking at kind of monolith type applications like Magento or Cilius, or, well, actually name anything really that's most PHP type platforms, you're looking at systems that are going to look like this. You've got Nginx handling web requests, passing through to PHP, and it calls out to kind of back-end services. Usually it's MySQL, but here I've used examples of Postgres and Redis. And this in itself is a layered system. Even within the confines of a single server, you've got layers going all the way down. You've got, Nginx takes a request, something that processes it, and it hands over to something else. The problem that we have when we're relying so heavily on cache is the problem of the cache stampede. And how many people have operated sites that have been under quite considerable amount of load before? Where you're alive because the caches are populated and they're serving up content from there, and you're sitting there watching the servers and hoping that nobody clicks the clear cache button. And we've actually been in a situation where we've had a system like that. It was actually a Magento site, and they just run an advert on primetime television, Saturday night in the UK, BBC. They just run an advert, and they spotted a typo in the CMS on one of the pages that they were directing people to go to. Can anyone guess what they did next? Yeah, they fixed the typo, which in itself wouldn't have been a problem, because if it waited for the cache to invalidate and everything had happened normally, the site would have been fine, because it would just trickle through and everybody would be able to handle it without too much of a problem. But what they actually did was they clicked refresh all caches, and it cleared everything out of Varnish, everything. And then suddenly about 25,000 people hit Magento running on a PHP server all at the same time. That took ages to recover from. And issues like that have real cost associated. When you've got a busy e-commerce platform, a busy site, having that period of time where the site is down, the amount of lost revenue that you can have through that, it adds up by the minute. It's incredible. And I think that outage cost them, for a typo, I think it cost them something in the region of £200,000. And it affects the bottom line for these businesses and companies all the time. And Spryker was built with that, having been through the pain of having to do all of that stuff over and over again, and building these systems and watching people clearing the caches and watching sites fall flat on their face. And so they kind of engineered their way around the problem. And what they did was they built a platform that actually takes performance and stability and uptime and speed at the core, as a kind of core reason for being. And this is kind of what it looks like. Spryker itself actually consists of two different applications. Eve, on the look over here on the left, and Z. In an earlier incarnation, it was called Alice and Bob. And then it became Eve and Z, and then it became Spryker. And it's been in development in various iterations for a long time. And I'm not quite sure exactly what the starting point was, but it was many years ago. And what they've done with Eve is they recognize the fact that when these systems go under load, and they do, and they can do, especially after primetime TV commercials and things like that, the thing that usually causes the bottleneck is almost always the persistent storage. You can scale up the reads really quite quickly, but what happens is when you get lots of data coming in, or you're doing lots of reads, you're going to lock up this bit really fast. You get deadlocks, you end up with just connections maxing out all over the place. And normally the web servers are usually kind of And with this system, what they've done is they've actually just taken the database away from the front end. So Eve itself, which serves up your shop front end, the thing that people go to when they go to www.myshop.com, there is no direct connection from here to here. All this thing can speak to are Redis, well, there's a key value store there, for example, Redis, and Elasticsearch. And the whole thing is powered off of those two in-memory memory systems. All of the hard, like the processing backend, all of that stuff happens in a completely discrete application. It's a completely separate application, although it's the same code base. It's not microservices that they don't even claim to be a sort of microservices architecture. They actually claim to be, well, I can't remember what they have a prefix for the word monolith, and I can't remember what it is, but it is a monolith of sorts, but it's actually a very nicely architected monolith. These are the same code bases, they're two different document routes within the same code base. And Z is the one that has the connection to the database. So it can read and write the database for persistency, and then pushes data into both Redis and to Elasticsearch for Eve to read and serve up on the front end. And this system scales. It goes really fast, it flies. And they did, last year at some time, they wanted to see quite how much it scaled. And they did a bit of a load test on Heroku. And they used a single performance L dyno on Heroku, which basically maps to Heroku, basically they're a platform as a service that sits on top of AWS. A performance L dyno has 14 gigabytes of RAM and 8 CPU cores. And this is just on a single performance L dyno, they achieve somewhere between 5,000 to 10,000 requests per minute on one server. And that's across the site. They actually recommend at least 3 for both Eve and Z, just for availability reasons. But the key point is this last one, is that it scales linearly. So where they could do 5,000 to 10,000 requests per minute on a single performance L dyno, they were expecting to be able to do somewhere in the region of 90 to 100,000 if they had 10 of them. Now 10 performance L dynos would set you back about €5,000 a month. And so they did it. They achieved a response time of 224 milliseconds with 81,500 requests per minute. That's the peak there. Response time never went above a quarter of a second across the site. The CPU usage, interestingly, when we looked at it, was at 6,710%. And we scratched our heads a little bit, it's like, what does that mean? But then we realized that you're talking about something in the region of 80 CPU cores. So yeah, that worked out. And it used 55 gigabytes of RAM at peak, under peak load. Actually what happened when we hit that amount of scale was the servers were sitting there handling it fine. I think they were about at 83% capacity, but they started running out of network capacity at Heroku. So we had to stop the test at that point. And it could have gone quicker, it could have gone faster. And if anybody ever comes across a site that needs to be able to do 81,500 requests per minute, I would love to see their revenue stream, because that's serious volumes of data. So Eve itself as an application is deliberately designed to be very lightweight because it's, you need it to be fast. This thing that at its core has to be quick. So it can only access data from in-memory scalable data stores, Elasticsearch and Redis. And it has a number of ways that you can actually update data in the back end. But it does it via kind of an RPC call. So it goes from PHP to initiates a separate call to Z to actually write data, things like add to basket, placing orders, making calls to other services. Eve won't do that directly. It will initiate a call to Z, and Z will make a call to a third party on its behalf. A call to Z, they've measured at an average of taking at least 70 milliseconds overhead. So you can only do one of them for a request. So the thing is that what they're really doing with Spryker is they're putting constraints around the stuff that developers can do in order for the system to be fast. And then you've got Z. So Z is for admin users. Z handles traffic coming from admin users. Let's imagine there's an arrow going at the top with admin users. It handles requests coming in from Eve. And then it has Elasticsearch, Redis, and Postgres sitting underneath it. It also pushes, I mean, by virtue of the fact that it can push data out to Elasticsearch and Redis, that's how the stuff actually hits the front end. And Z contains all your business logic and a state machine, which is used for order management. So at that point, after an order has been placed, there's a whole lot of logic in there to say, okay, well, what has to happen? What's the process of getting the order from the top down to the bottom and getting it shipped out to the user? And what they've done is they put the cache there. By powering the front end from Redis and Elasticsearch, they've shifted that layer from what we were looking at before. They've shifted the cache from being in front of the application to actually being part of the application. It's actually in the middle. And that's how they can achieve that kind of the awesome scale that they can do. And you don't have to worry too much about cache invalidation. Because you don't have a full page cache. It doesn't do it. And really famous quote from Phil Carlton: two hard things, or three hard things in computer science: cache invalidation, naming things, and multiply one errors. But and Spryker managed to avoid this problem completely by not having a full page cache and not. You can put tools like Cloudflare in front of it. Who's got Cloudflare running in front of any sites? So a few people have seen Cloudflare. And more layers are always useful. Cloudflare adds really cool stuff like a web application firewall to enhance your security. It can add a full page cache. It can optimize CSS and JavaScript and HTML. It can do SSL termination. And all of those things add even more performance onto the site. But Spryker doesn't need to offer things like full page caching out of the box. So that is an overview of Spryker and the way that and how it lives on top of servers and how it exists as a thing. So if we dive a little bit into what Eves and Z actually are and how they're made up. Eve consists of two components. It has a load of controllers and it has a client. And controllers are the entry point for the system for front-end users. That's everybody understands what controllers are. Very similar to the way that Symfony does it. In fact, actually, both Eve and Z, I think they're using they use Silex as their kind of their root in. So because it's Silex, it uses Symfony components underneath. It has they're using Twig for all their templating. But the interesting thing is that with the controllers, because it's really it's so lightweight and so simple, you can actually throw that whole thing away and build whatever you like, and build in whatever you like. All you really need is the client, and I'll talk about the client in a minute. The interesting thing is that what you could actually do is you could build plugins for things like WordPress, or for Drupal, or for anything you could imagine that simply makes use of the Eve client to talk to Z on the back end. The thing that's actually displaying your website to end users could be anything at all. But yeah, the demo shop ships with a really lightweight implementation of Silex that you can build controllers in, and it provides everything that you need to do that. You could even replace the controllers with a kind of a headless, something headless, and put an API on top of it. It's very, very flexible on that front. But the Eve client, that is what's providing access to the data that's stored in the storage, Redis, Elasticsearch, and provides the connection back through to Z. And the client itself So the bottom two things you can do as many as you like of. You're not limited in any way on calls to search and calls to Redis, because the amount of overhead that they have is minimal. I mean, especially Redis, 0.1 to 1 millisecond per get. But yeah, as I mentioned before, you get one per request if you need to make a call back to Z. It makes heavy use of transfer objects. For a number, in fact, actually, you can use transfer objects for pretty much anything when you're using Spryker. You'll see them absolutely all over the place. And all transfer objects are they're just simple data containers. They just say on the website kind of a standardized way to access data and get expressive method signatures. They're available absolutely everywhere, and you define these objects in XML, which is kind of weird when you first start looking at it. Basically, you create XML files, and then you run a PHP script, which then spits out a load of PHP classes from those XML files. But it does kind of work. It doesn't sound completely crazy. And they look a bit like this. I mean, the reason why they do it like this is so that you can never be tempted to put any logic whatsoever into those PHP classes. So they make you define them in XML so that you actually can't put logic into those classes. I mean, they're completely generated. And what these will do when you create them, you can build you can have as many of those as you like, and then you use them inside PHP like this. You know, you just set values on them, and you can read values back out of them again. They're completely mutable. And Spryker uses them all over the place for, you know, if you want to build something, you want to send some data to the back end, you build one of these things, you populate it with your data, and you host it using an RPC call to Z. That's essentially all there is to Eve. I mean, it's really, really, really simple. It has a Twig template renderer, and it makes use of these things, and it makes use of the client. It's a super simple thing to work with. And that leads us on to Z. And Z's quite a lot more, there's a lot more to it, there's a lot more layers, there's a lot more things to think about. And this is where all of the kind of, the real sort of software engineering side of things comes into Spryker. It kind of only has 3 layers, but I put 4 in just because I always think that what Spryker says is that the communication layer kind of encompasses the presentation layer. Which I suppose it does in a way, but the presentation layer for me is different because it's Twig templates. It's the thing that converts you have your controllers in there, and then you need to take the output of the controller and then do something with that to turn it into HTML. And that's kind of like the presentation layer. The communication layer. I'll talk about the communication layer on the next slide. But for now, all we need to know really is that there are different layers in which you have to traverse through in order to make things happen. The communication layer consists of controllers and plugins. So these are separate to the Eve type ones, although they are still Silex. It is still Silex underneath the hood. You have a lot less control in Z over the way how URLs map to controllers and actions. It handles a lot more of that kind of side of things for you. On Eve, you can very easily, it's kind of designed around making things, you know, very nice SEO-friendly URLs and having nice things that look nice and work well with browsers. Controllers are obviously the entry point, and plugins are pulled in from other bundles. You can have lots and lots and lots of different things that are happening inside this layer. They're responsible for accepting user input, delegating to the business layer. That's essentially all you need. That's all the communication layer should do, is accept user input and as quickly as possible delegate anything that needs to happen off to the business layer. And then handle any results, handle that off to the presentation layer to deal with. That's the communication layer, that's all it needs to do. To delegate stuff down to the business layer, there's this, it makes use of a facade pattern. So from the communication layer down to the business layer, you need to go via the facade. And the only thing that's actually that Spryker defines about the business layer is that you have a facade, and the facade is your API, essentially. It's your API onto everything that needs to happen as a result of a web request. business layer has to extend one class, an abstract facade, and the only thing that it really allows, that it provides, is a way of being able to get hold of the factory. And you need a factory to be able to create any of the other objects that are inside the business layer. And when you look at the bundle from another bundle, you only see the facade. You can only see that. So all of the implementation that's underneath it is kind of hidden away behind that facade that's in there. That really helps keep the bundles decoupled. There's a real strong focus on making sure that we don't have like loads and loads of interdependencies between different bundles. It makes them really testable. It makes you can test pretty much everything inside the business layer really easily because it's not really dependent on anything else in the system. And it helps with things like being compatible with future updates. You can basically completely throw away an implementation inside one of your bundles and just make something that adheres to the same API, and you can refactor things and not break everything as you go forward. And then from the business layer, if you need to drop down to the persistence layer, which is the lowest layer that you can hit really, then you need to use this get query container command function to be able to then to actually persist data out. So the business layer, it knows about the business object, it knows about the objects, it knows about all the business logic. Most of the code is going to sit there, but it does not know how to persist stuff. And to be able to persist things from the business layer, it has to go via the query container. And the query container contains all of your database queries. Spryker, by default, bundles Propel. I don't know why. I don't know why they chose to use Propel. I think they just liked the simplicity of it. It kind of seems to work for them. And yeah, so they use the Propel or it supports MySQL or Postgres. Most installations, in fact, all the ones that I've seen through Spryker, everyone uses Postgres because it has like some really extra things that can make it really useful to use Postgres. Every bundle has a dependency provider because it's Silex. I think they've kind of always rolled with using Pimple for doing that. And you provide dependencies to other bundles, to things like for the persistence layer, the business layer, and the communication layer via locators on the container. So you construct everything inside that dependency provider, and Spryker will automatically pass all your dependencies in and out via Pimple. And that provides all the lazy loading functionality. But anyway, what that kind of ends up with is it sounds like an awful lot of work. And it kind of is an awful lot of work. A really simple Hello World bundle to basically to get something from kind of nothing to being able to display, oh, Hello World, I exist and I'm registered and set up and working with Spryker and on Z on the back end. You need to create 12 new classes just to be able to do that properly. When I first started working with Spryker 12 months ago, we had to create all 12 of those classes manually. It took us a day to do Hello World. And what they have now, which is so much nicer and so much better, is they actually have just code generation for this stuff. It makes it very difficult to cheat. It makes it... I always like, when I'm learning something new, I like to be able to kind of say, all right, what's the absolute most minimum amount of stuff that I have to type in order to be able to make something happen that I want. Spryker kind of doesn't let you do that very easily. And you have to create all the classes how I want you to create them, because there's just very little in the way of being able to shortcut how it works and how the system actually all hangs together. For Eve, it's a lot simpler because it's so much lighter. I mean, actually, Hello World and Eve is only like 3 classes. But what you get as a result of doing all of this work, and they're trying to make it easy by providing all of the code generation and all the other things that's there, what you get are these really decoupled layers that are really easy to test. And it's really maintainable. It sounds like a lot of classes, but once you set it up, it becomes really easy to then change going forward. You can swap things out, you can change things, you can be really productive with the platform. It is super opinionated, in that it's of the opinion that you should always be writing clean code. And it prevents you from shortcutting the system. You can have your own kind of, I guess everyone will have their own kind of opinion on whether or not that's a good idea. I personally think it is, and I've seen so many disasters with e-commerce platforms and things that have landed on that have come in and saying, oh, we have loads of problems with performance and loads of issues with bugs and things going wrong, and you take one look under the surface of what's going on, and you just want to close your laptop and walk home. And Spryker, although you still can make those kind of mistakes with Spryker, it really tries hard, very hard, to steer the whole development team in the right direction of writing good, clean code. Yeah, this is just a quote that, actually if you read through the Spryker documentation, it makes a few references to clean code by Robert Martin. I think the key point there really, if code isn't clean, it can bring a development organization to its knees. Countless hours of significant resources are lost because of poorly written code. And Spryker, they definitely recognize that. They recognize the fact that performance is so key for a successful e-commerce platform, and that being productive on the platform and having clean code underneath it is really, really important. And they've engineered that system around those two issues. That's the core concerns. They won't sacrifice performance and they won't sacrifice code quality. They by far have the highest scrutinizer score out of any kind of framework that I've ever used. I think they're up in like, I don't know, 9.7 or 9.8 or something like that in scrutinizer. It's quite impressive. And the last thing that I wanted to talk about, which is something that's a really cool part of Spryker's backend, is the state machine. It's one of the things that when you actually see it working, and you've worked on other e-commerce platforms and OMS type systems, that you kind of see this one working and how easy it is to change stuff, and you think, oh, if it's this easy, why isn't anybody else doing it? And you kind of get a little bit worried that there might be something wrong, but it's really, it really does work. It works really well. And I think you get state machines now, I think Symfony have just released a version, I don't know, maybe 3.1 or 3.2, I can't remember. You have, is it workflow? The workflow? Yeah. Which I think is kind of similar to this. And in fact, actually, had that been around when Spryker were figuring out how to do all of this stuff, they may well have used that. But the state machine consists of states, events, and transitions. And what you can do is, like, the states. Actually, I'll back up a little bit and explain a little bit about what you use the state machine for. So, when an order is created, it goes into the system in a state of new. It's a new order. And as it progresses through the kind of order fulfillment, you need to take payment, you need to prepare the item for shipping, you need to get it shipped, you need to be sending it a delivered state or a returned state. I mean, there's all sorts of different things, and for every e-commerce installation, that is always going to be different. With lots of platforms, they kind of try and force you into fitting your business process into a kind of predefined list of states. You can't add them, you can't really change them very easily, or it becomes awkward. And what Spryker is delivered is giving you this kind of really generic system that you can say, okay, just give me a list of states, give me a list of things that can happen, and give me a load of transitions. Now, events are things like sending an email, or making a call to a third-party service. And transition is a combination of what state you're going from, what state you're going to, and what event do you want to trigger when that thing happens. You define it all in an XML file. Again. This is a really, really small version. These things can be massive when you get quite complicated. When you get into quite complicated business logic. So you have this is defining two states: one of new and one of waiting for payment. has one event, and it has a transition. Now you can attach code to events here. So if you want to run something, you can pass it like command equals like a class. So when you're going from new to waiting for payment, trigger that event. And you pass through the system like that. And you can visualize these things. Once you've, I actually don't have a screenshot of it because I added this morning to the presentation because I thought it was quite interesting. But I don't have a screenshot of it yet. But you can actually visualize these flows in a big graph. And at Spryker Office, they have like an A1 printer. And when you visualize it on a screen, you can see, okay, everything always starts at new. Every order always starts at new. And there's like a whole lot of different paths and breakout points and things that could possibly go wrong and what happens on those things. All the way down to kind of successful delivery or items being returned. And they can just be enormous, they can be huge. But the great thing is that you can actually discuss this with your client. And you can say, rather than have a conversation about, oh, the state is that one, I need to go to that one, I need to do something here, and then try and code that up. You can actually show them on a piece of paper, on a printed out piece of paper, the actual thing as it happens on the site. So if there's a bug that they can see on the site, they can be confident that bug exists actually in the system too. And that's a really powerful tool, it's a really powerful thing to be able to do. In my experience, Spryker, whether you're working on the front end or working on the back end, it's super easy to extend it. You can follow the code really quite easily in most places. It's actually fun to work with, which is quite unlike most software vendors. And every team that I've worked on with that's been using and building commerce websites using Spryker has been really highly motivated. The amount of work that we've been able to get through, even in the first kind of early days of a project, has been actually quite phenomenal. Like usually you have this kind of really slow start to projects, and the ability you build up over a little period of time. With Spryker, because the code quality is so high, you're not fighting it all the time. It actually becomes quite a motivating factor for the team that they can actually get stuff done. They're going into work, sitting down, working on something that actually lets them produce something that they can see visible change at the end of the day. And they haven't spent the entire day fighting with something that doesn't work that should be. And that's Spryker. Does anybody have any questions on any of the things to do? I've actually put, if you want to know more, the Spryker.com website is there. It has a link off to the documentation, Spryker, the technical documentation, spryker.github.io. Has anybody read any of these books? Yeah. So if you've read, especially Principles of Package Design, lots of the stuff that I've just said will sound really familiar. They've kind of architected around those kind of principles. Anyway, they've taken off in their own direction in a couple of places, but it's mostly the stuff that's in this book. The documentation, as I mentioned before, references clean code quite a lot, and they've built that whole platform off of the learnings from years and years and years of doing this. Anyone got any questions they want to ask? Yeah.
How does multi-language support?
Yeah. So the demo shop that it ships with, I mean, they have multi-language just out of the box. Actually, it works off of using, in the back end, they kind of have like a glossary lookup, so you kind of see the database with kind of, there's a whole lot of ways of doing it, but you have kind of little placeholder tags. In Twig, they have a little function that has a custom extension which pulls all the translations out of the database, but it all works basically through the same system. So all of those translations, all of those things are all fired into Redis, and E will pull the relevant bits of data out and translate them in line. German and English are what come with the demo shop. So they have that all pre-set up, but like to add new languages, I think the site that we're currently building, I think will ultimately have at least 3 languages, I think, maybe even more going forward. But it's a really quite a trivial thing to add new language and translations in. It's all managed through the back end as well, so you can do it. You can do it from the database. You don't need to change code or anything like that, or change files that are in version control to add translations or change them. So it works pretty well. Any more? Yeah.
Can you show some example?
The demo shop.
Code.
Yep. I don't know if I should, but this is.
Can you show some overall application that you use for one day?
Oh gosh. Hey, I'm a CTO. I don't write code anymore. I don't have anything I can show right now.
But just the GitHub repository of the demo shop gives an idea. Yes.
Yeah, it's open code. So you can go to so Spryker, the licensing is it's open code. So as developers, you can go and download it, you can install it, and you can start playing around with it. You know, look at the code quality and check it out for yourself. It's all in GitHub. It's kept completely up to date with everything. You can start playing around with it. But in order to use it in production, or actually even to start really developing a real site, you need to speak to them about getting a license. So there are, it is proprietary code. It's not open source in a sort of that you can just install it and run your own site on it without getting involved.
How is this licensing works? Is it like IonQ modules?
No, they don't bother with any of that. If you wanted to steal it, you could. Put it that way. but I wouldn't endorse it or recommend that you do.
So just some calls, right?
Yeah, all the code is completely publicly available. It's all on GitHub. So even the demo shop, they just trust that they will. That any project that's going to be built using Spryker would go via them, and they just expect you to declare, "Hey, I'm using Spryker. Here, have some money."